Good morning, students. Let us now discuss, as part of revision, a model paper in mathematics, okay, before your quarterly exam. Let's look at a few questions, students. This model paper has been sent to you for practice. Today, I'll be discussing this paper so that you understand how you need to write the answers. All right, students, let's start the discussion now. Let's go question by question and discuss the concepts. First one, the interval form of x, where x belongs to set of real numbers from -3 to 0. As you can clearly see, it is only less than, it is not less than or equal to. Therefore, -3 is not included. 0 is not included, but everything between -3 and 0 is included. So the right answer for this will be -3 to 0. Correct, students? So which of the options is correct? Second option. Correct? Suppose if I say -3 less than x less than 0, then we will write it as open interval -3, 0. Suppose it had been -3 less than or equal to x less than 0, then -3 is included. So I'll put a closed interval here, but 0 is not included. Suppose if this was the question, it means -3 is not included. So open interval here, but 0 is included. So I'll place a closed interval here. Suppose it is -3 less than or equal to x less than or equal to 0, then all values between -3 and 0, including -3 and 0. Hope it is clear to you, students. Okay, we'll move on to the next question. Question number 2. If A cross B is P, Q, P, R, M, Q, M, R, then what is the set D? In fact, if you see, all these first elements in the ordered pair are all going to belong to A. So what are the elements in A, dear students? P and M. Right? Let's now look at what would be B. So all those elements which are coming second in the ordered pair, they are going to be belonging to B. For example, Q, R. I hope it is clear to you, students. Now, from here, we can clearly answer what is set B. Set B is nothing but Q, R. So the right answer for this is option C. Clear, students? Shall we move on? We need to find out the value of sine 765, right? 765 is a number greater than 360. So you divide by 360 2 times, so you get 720. Remainder is 45. Therefore, I can write 765 degrees as 360 into 2. That will become 720 plus 45. Clear, students? Therefore, sine 765 can be written as sine of 360 into 2 plus 45. And as I have told you earlier, whenever you have 360, it is just a rotation, one complete rotation to the same position, right? Suppose we have a ray, OP. If I'm going to rotate it by a 360, I'm going to come back to the same position. If I rotate by another 360, again I come back to the same position. So in the next step, I can write it without considering this. So that will be sine 45. And what is sine 45 from our table, students? 1 by root 2. Therefore, the right answer for this question is 1 by root 2. Hope it's clear. We move on to the next question. Okay, students, let complex number z be equal to 3 plus 2i. Then what is the real part of z? See here, complex number is given by the form a plus ib, where we know that I is square root of minus 1, right? In this, the real part of z is the component without this I. So which is a. Imaginary part of z is going to be the component which is with I. B. Is that clear, students? So now you can clearly see when I say z is equal to 3 plus 2i, the real part is a, which is 3. The imaginary part is b, which is 2. Clear, students? Therefore, here we are asked to find what is the real part of z. Real part is the one without the I, which is nothing but 3. Therefore, the answer is the first option. Is it clear, students? Now let's move on. Find the degree measure of 2 pi by 3. Okay. Two pi by 3 can be written as, this is 2 pi by 3 radians. We have to convert it into degree. We know that pi radians is equal to 180 degrees. Therefore, 1 radian will be equal to 180 divided by pi. Therefore, to convert from radians to degree, I just need to multiply with 180 by pi. So pi gets cancelled. 180 by 3 is 60. So 2 into 60 will be 120 degrees. Therefore, the right answer for this question is second option. Is it clear, students? Let's move on to the next part, which is fill in the blanks. Now we are supposed to answer these questions. And the correct answers are given. All right, students. Okay, now let us answer each question one by one. Sixth one. A function f is defined by f of x is equal to 2x minus 5. Now, what will be f of minus 3? So, in this equation, wherever x is there, we will now substitute minus 3. So, what happens, students? 2 into minus 3 minus 5, correct? Wherever x was there, I have substituted minus 3, correct? So 2 into minus 3 is minus 6. Minus 6 minus 5 is minus 11. Therefore, for the first one, the answer is minus 11. Clear, students? Now let's look at second question in filling the blanks, which is the question number 7. We have to find the value of I to the power 4. We already know that I represents complex number, which is root of minus 1. So what will be I square, students? It will be nothing but root of minus 1 the whole square, which will become minus 1. So when I say I power 4, it is nothing but I square the whole square. Do you agree? And what is I square? I square is minus 1. So minus 1 the whole square becomes 1. Therefore, the required answer for the 7th question is 1, which is nothing but the value given here. So the answer for this is 1. Clear, students? Let's now look at question number 8. Let A and B be disjoint sets. What do you mean by disjoint sets? No intersection or no common elements. Then you know very clearly, if A and B are in disjoint sets, then what is going to be A intersection B, students? Yes, it is a null set. So how many elements will be there in it? Nothing. So number of elements in A intersection B will indeed be 0. Therefore, the answer for the 8th question is the left out option which is there, which is 0. Is it clear, students? Quite simple. Yes. Now let's move on to the next section. Answer all the following questions. Let's look at question number 9 now. If sin x is equal to 3 by 5 and x lies in the second quadrant, then what is the value of secant x? Okay, students. Now, we can do it in multiple ways. One of the ways is using the identities. Okay. We all know that sin square x plus cos square x is equal to 1. So what is cos square x? 1 minus sin square x. So which means what is cos x? That will be plus or minus square root of 1 minus sin square x. Clear? Now in this question, what is given? Sin x is given. Sin x is 3 by 5. Therefore, sin square x will be 9 by 25. Right, students? Therefore, this is plus or minus root of 1 minus, what is sin square x? 9 by 25. So when I take LCM, I will get 25 minus 9, which is 16. Root of 16 by 25. I will get plus or minus. What is root 16, students? 4. Root 25 is 5. So I get cos x as either plus 4 by 5 or cos x is equal to minus 4 by 5. Now, because the angle is in the second quadrant, right? Second quadrant cos is negative. Only sine is positive, correct? We know the ASTC rule, right, students? All trigonometric ratios are positive in the first quadrant. In the second quadrant, sine and its reciprocal are positive. In the third quadrant, it is a tan and its reciprocal which are positive. And in the fourth quadrant, cos and its reciprocal are positive. This is what we call as ASTC rule. Going by that, because the angle is in the second quadrant, cos x cannot be positive. So we have to choose the negative answer. So cos x is minus 4 by 5. We want the value of secant x. Secant x we know is what? The reciprocal of cos x. So it should just be the reciprocal. Minus 4 by 5 reciprocal is minus 5 by 4. Therefore, the required answer for this question is minus 5 by 4. Clear, students? All right. Okay. Now, another way of answering this question is, of course, it's given that the angle is in the second quadrant. So the ray will be like this, where if you see, this length will be 3 because it's the opposite. And the hypotenuse is 5. And using Pythagorean triplet, we can get that this will be 4. So cos will be 4 by 5. Secant will be reciprocal of that, which will be 5 by 4. But because it is the second quadrant, we know that cos and secant are negative. You can have a minus sign. Or in other words, the x coordinate is negative, right? In the second quadrant. All right. So this is another way of getting the same result. Whichever is convenient to you, you could use. Okay. Now let's move on, students. Let's move on to the next concept. Okay. The last one more question. If set A has 3 elements and set B is given by 3, 4, 5, find the number of elements in A cross B. A cross B refers to the Cartesian product. We know that number of elements in A cross B can be simply obtained as the product of number of elements in A multiplied by number of elements in B. Number of elements in A is already given. It is 3. And number of elements in B we can count. How many are there? 3. So here it's already given. Number of elements in A is 3. And the set B is given as what? 3, 4, 5. Which means the number of elements in B is going to be 3 as well. So 3 into 3 is 9. Therefore, the answer to the 10th question is going to be 9. I hope it's clear, students. Let's now move on. We now come to 2 more questions. You need to answer any 3 out of the given 6 questions. Each question carries 2 marks. All right. So let's take each question and solve them now. Question number 11. Prove that cos 3x is equal to 4 cos cube x minus 3 cos x. Students, as a starting point, let's remember this result. we know that cos 2x can be written as cos squared x minus sin squared x, or we can write it as 2 cos square x minus 1, or we can write this as 1 minus 2 sin square x, or we could write this as 1 minus tan square x divided by 1 plus tan square x. Now, among these formulae, right, if there is a need for us to substitute for cos 2x, we will go for this one among these four. What is the reason, students? Because if you see, in the entire equation, we are supposed to get in terms of cos x, right? That's the reason whenever we need to apply cos 2x formula in this, we'll be using cos 2x is equal to cos square x minus 1. Okay. With this background, let's move on to solving this question. So let us write LHS is equal to cos 3x. Now, cos 3x, how could I write it? Cos of 2x plus x. Am I right? This is of the form cos of a plus b. And you know that cos of a plus b is cos a cos b minus sin a sin b. Or if you're comfortable with x plus y notation, you can go ahead with that. Cos of x plus y is cos x cos y minus sin x sin y. Okay. So LHS is equal to, so it's like cos of a plus b. So cos a cos b, so it will be nothing but cos 2x into cos x minus sin 2x into sin x. Right, students? Now, what did I tell you earlier? Wherever cos 2x is coming, we are going to substitute it as 2 cos squared x minus 1. Clear? And I have this cos x which is outside. And sin 2x, I hope you know the formula for sin 2x. What is sin 2x, students? 2 sin x cos x. Of course, there is one more, 2 tan x by 1 plus tan square x. However, in this, we are going to substitute sin 2x as 2 sin x cos x. Clear, students? Then I have sin x here. Now, let's multiply this inside. 2 cos x, 2 cos square x into cos x. That gives you 2 cos over 3x. Then I multiply 1 minus 1 with cos x. So you get minus cos x. Then we multiply sin x with the sin x. So that gives you 2 sin square x into cos x. Please observe, students. So far, is it clear to you? Okay. Now, so let me write the first two terms as it is. Now, I don't want any sine term here, right? So what would I do? We know that sin square x plus cos square x is 1. So sin square x, we can write it as 1 minus cos square x. I'm sure in your 10th class, you would have done this several times, right? Substituting sin square x, 1 minus cos square. So 2 into sin square x, I'm going to write it as 1 minus cos square x. Clear, students? Into the cos x which is there. So the sin square x, I'm writing it as 1 minus cos square x. So what we have got now, 2 cos cube x minus cos x minus, if you see, just observe carefully, this is 2 cos x multiplied with 1. So what do you get? 2 cos x. Then minus into minus becomes plus, plus 2 cos x into cos square x. So that becomes plus 2 cos cube x. So now let's conclude. We are in the last step now. As we can see, we have 2 cos cube x plus 2 cos cube x, which gives us 4 cos cube x minus cos x minus 2 cos x. We get minus 3 cos x. And that is exactly what we needed to prove. That's equal to our RHS. Please go through it, students. Let me know if it's very clear to you. Okay, students, I hope it's very clear to you. Let's move on. Let's move on to the next question, students. Question number 12. A very simple question from sets. Set A is given, set B is given, set C is given. We need to find out what is A intersection B union C. Let us compute what is B union C. So what have I told you, students? You just have to include all the elements in B as well as whatever elements are there in C once. So we'll write all elements in B. So that's 7, 9, 11, and 13. And all elements in C. So we have 11, 13, and 15. Since 11 and 13 is already entered, you don't write it again. So you will simply write the one which is missing, which is 15. Therefore, this is going to be your B union C. Yes, students. Now let's write down A here once again. A is 3, 5, 7, 9, 11. So what do we need to find? We need to find A intersection with B union C. Yes, students. So you can see the intersection, common elements in A and B union C. All right. So what element, which elements are common in both B union C and A? There is 7 here, there is 7 here. There is a 9 here, there is a 9 here. There is 11 here, there is 11 here. The other elements are not common, right? Therefore, A intersection B union C is going to be simply 7, 9, 11. That's it, students. Very simple question. I'm sure you followed it and you are very clear with this. Okay, we will move on. Okay, students. Now, A is equal to 1, 2. Then form the set A cross A cross A. Okay. So first, let's do A cross A, which is very familiar to you. Set A is 1, 2. Set A is 1, 2 again. So A cross A will be nothing but the ordered pairs, right? 1, 1, 1, 2, 2, 1, and 2, 2. Is it clear, students? Now, we need to do A cross A cross A. Okay? Which means I have the set A cross A is given here. What is A? 1, 2. So we will have to relate now each element here. What is there? 1, comma 1. We have to relate it with 1. Comma 1, comma 1. We have to relate it with 2. Then, now we go to 1, comma 2. 1, comma 2. We relate it with 1. Comma 1, comma 2. We relate it with 2. Clear, students? Now we've finished relating these two. Now let's do the next. Now 2, comma 1, comma 1. 2, comma 1, comma 2. Then finally, it is 2, comma 2, comma 1 and 2, comma 2, comma 2. That is the required set A cross A cross A. Clear, students? So totally there will be 8 elements. 2 into 2 into 2. 8 elements will be there. Clear, students? Now let's move on. Let's look at 14th question. Find the value of sine 15 degrees. Sine 15 degrees can be written as sine 45 minus 30. Yes, students? Or you could also write it as sine 60 minus 45. And then use the formula sine of A minus B or x minus y. What is sine of x minus y? Sine x cos y. Or sine A cos B minus cos A sine B. Clear, students? So we will use that. So sine 15 degrees is going to be equal to sine 45 cos 30 minus cos 45 sine 30. Sine 45 is 1 by root 2. Cos 30 is going to be root 3 by 2. Cos 45 is 1 by root 2. Sine 30 is 1 by 2. You must have the tables which you had learned in 10th in your fingertips. So this becomes root 3 minus 1 by 2 root 2. Right? I hope tables are clear with you. Let me just quickly write it for you once. 0 degrees, 30, 45, 60 and 90. The basic angles. All right, students. Sine 0, 0. Sine 30, 1 by 2. Sine 45, 1 by root 2. Sine 60, root 3 by 2. Sine 90, 1. Let's write it for cos, students. Cos 0, 1. Cos 30, root 3 by 2. Cos 45, 1 by root 2. Cos 60, 1 by 2. Cos 90, 0. Tan 0, 0. Tan 30, 1 by root 3. Tan 45, 1. Tan 60, root 3. And tan 90 is 1 by 0, which is not defined. And the reciprocals, I hope you can do it yourself. Cosecant is the reciprocal of sine. Secant is the reciprocal of cos. And cot is the reciprocal of tan. Okay, students? Remember those tables so that you can solve such questions very easily. Okay. Solve the question 7x plus 1 less than or equal to 4x plus 5 and represent the solution graphically on the number line. X is a natural number. Seven x plus 1 is less than or equal to 4x plus 5. So I can bring 4x to the side and I can take 1 this side. So this becomes 7x minus 4x less than or equal to 5 minus 1. 7x minus 4x is 3x. That's going to be less than or equal to 4. Or in other words, x is less than or equal to 4 by 3. So when we plot the axis, students, x-axis, this is y-axis, x is equal to 4 by 3. 4 by 3 is 1.33, right, students? Is a line which is parallel to y-axis. Right, students? So now, x has to be less than or equal to 4 by 3, which is nothing but 1.33, right? Which means we are looking for an answer to the left of x-axis, correct or not? But what happens is, left of this axis, x is equal to 4 by 3. And so on. Now, one more information that is given is, x is a natural number. There is only one natural number which is less than 1.33. And what is that, students? X is equal to 1. Clear, students? Because when it is a natural number, it can either be what? Either it can represent the line x equal to 1, or it can represent the line x equal to 2, or it can represent the line x equal to 3, and so on. When the value of x must be less than or equal to 4 by 3, then it is to the left of this line, number 1. So to the left of this line, there is only one line which is going to give you the, if the answer for the solution for this is the line x equal to 1. Is it clear, students? Okay, now next, let's move on. Let's do question number 16 now. Prove that sine 2x is equal to 2 sine x cos x. Students, we can start with the formula that we know for sine x plus y. What is sine x plus y? Sine x cos y plus cos x sine y. Right, students? Now here, when I say sine of 2x, how could I write this? I can write this as sine of x plus x. So if you compare it with this formula, wherever you are having y, you need to replace it with that also with x. Clear? So this becomes sine x cos y, but then y is also x here, plus cos x sine y, but sine is, that is also x. What is sine x cos x plus sine x cos x, students? 2 sine x cos x. Or if you want to write one more step, what you can do is you can take sine x cos x outside, so that you get 1 plus, you get sine x cos x is equal to, or sine 2x is equal to 2 sine x cos x, and hence the proof. So you can start it from your left hand side. That is equal to RHS, and hence proof. Is it clear, students? Okay, now we have completed all the 2 mark questions. Now we move on to the 3 markers. Okay, students, now let's do question number 17. Okay, now we have to verify whether A cross B intersection C is same as A cross B into A cross C or not. Okay, First, let's verify LHS. Let's find out what is LHS. For that, we need B intersection C. Elements which are common to both B and C. Just observe, students. B and C, do we have any element which is common? No. So B intersection C is nothing but a null set. Got it? So A cross B intersection C, which is nothing but A is 1, 2. You're crossing with, you're doing Cartesian product with a null set. So what's going to be the answer, students? It's yet another null set. Now let us check the RHS. Okay, for that we need to do two things, right? One is A cross B. What is A cross B? What is A? 1, 2 cross B. What is it? 1, 2, 3, 4. Now, how many elements would be there, students? There would be 8 elements. All right. So it would be 1, 1, 1, 2, 1, 3, 1, 4. Then you go for 2, 1, 2, 2, 2, 3, and 2, 4. That is your A cross B. Now try doing A cross C, students. A is 1, 2 cross C, which is 5, 6. So what do we get? 1, 5, 1, 6, 2, 5, and 2, 6. Now let's compare the two sets, students. We will have to compare A cross B and the set A cross C. Do you see any common element, students, between set A cross B and A cross C? Nothing, right? So A cross B intersection A cross C, there is no common element. Therefore, it is a null set. So we get LHS as a null set. RHS is also a null set. Therefore, from 1 and 2, we get that LHS is equal to RHS, and hence the proof. I hope it's clear to you, students. Let's go through it once. All right, let's move on, students. Let's move to question number 18. Prove that tan 3a is equal to 3 tan a minus tan cube a by 1 minus 3 tan square a. Okay, students. Now let's take left hand side. Tan 3a can be written as tan of 2a plus a. And we know the formula for tan of x plus y, right? What is tan of x plus y, students? Tan x plus tan y divided by 1 minus tan x tan y. Clear? So this can be written as tan 2a plus tan a divided by 1 minus tan 2a into tan a. Right, students? So from this, from tan of x plus y, we can also find tan 2a, right? What is tan 2a, students? It is nothing but tan of a plus a. You don't need to do the proof for the sum, but that is, I mean, tan 2a proof you need not do. You can just directly take it. But just for your understanding, I am doing it. So it is tan a plus tan a, because x and y are equal, right? Equal to a, divided by 1 minus tan a into tan a. Tan a plus tan a is 2 tan a. 1 minus tan a into tan a is tan square. Therefore, tan 2a can be written as 2 tan a by 1 minus tan square a. The value of which can be substituted here. Isn't it, students? We have solved it earlier. This would be a revision, just a revision for you guys. So this is nothing but 2 tan a divided by 1 minus tan square a plus tan a divided by 1 minus, again wherever tan 2a is there, I am substituting 2 tan a by 1 minus tan square a. Into tan. Now we are going to continue here. So if I take LCM, it is 2 tan a plus I have a tan a here. When I take LCM, this 1 minus tan square a comes here. Divided by 1 minus tan square a. The whole thing divided by 1 minus tan square a. The LCM is going to come here. Minus tan a into tan a. So that's tan square a. So 2 tan square. Divided by 1 minus tan square. So what gets cancelled, students? 1 minus tan square a gets cancelled. In the numerator, let's write all the terms. So this is tan a into 1 is tan a minus tan a into tan square a will be tan cube a divided by 1 minus tan square minus tan square a minus 2 tan square a. That is minus 3 tan square a. And this next step would be our last step, students. 2 tan a plus tan a is 3 tan a. Minus tan cube a. The whole thing divided by 1 minus 3 tan square. That would be our final answer, which is equal to your RHS, what you needed to prove. Is it clear, students? First, you write tan 3a using the formula tan of x plus y is 2a plus a. You write it in this form, then substitute the formula for tan 2a and then take LCM and simplify. That's it. Is it clear? Shall we move on to the next question? Okay, students. Now we have f of x is equal to x square and g of x is equal to 2x plus 1. What is f plus g into x? G of x. Simply f of x plus g of x. So it should be nothing but x squared plus 2x plus, that would be our answer. Is it clear, students? Now let's look at, again, f of x is x squared, g of x is 2x plus 1. This is f minus g of x, which will be nothing but f of x minus g of x, which will be equal to f of x is x square, g of x is 2x plus 1. Therefore, the answer is going to be x square minus 2x minus 1. Is that clear, students? Yes, students, I hope it's clear so far. Now, we do the last part of this question. So it's the first part, the second part, and the third part of the question, which is nothing but fg of x, which is nothing but the notation for f of x into g of x, students. What is f of x? X square into g of x, 2x plus. Just multiply, students. X square into 2x, that would be 2x cube plus x square into 1, that will be x square. Therefore, the answer will be 2x cube plus x square. I hope it's very clear to you, students. We will move on to the next question. Let's look at question number 20. Express the complex number. Let's say the complex number is given by 1 minus I divided by 1 plus I. Express it in the form a plus ib. Okay. So what is that we do? We rationalize. We multiply and divide with conjugate of the denominator. What is the denominator function, students? 1 plus I. This number's conjugate will be 1 minus I. So I will multiply numerator and denominator with 1 minus I. So tell me, students, what do you get? Numerator, you get 1 minus I the whole square. It's of the form a minus b into a minus b, which is a minus b whole square. Denominator is of the form a plus b into a minus b, which will be a square minus b square. Do you agree, students? Correct? 1 plus I into 1 minus I. So that would be 1 square minus I square. Clear? So numerator is a minus b whole square. So a square plus b square minus 2ab. So it is 1 square plus I square minus 2 into 1 into I divided by 1 square is 1 minus of I square is minus 1, right? We know that I is equal to square root of minus 1. Therefore, I square will be equal to minus 1. So in place of I square, I am substituting minus 1. Clear, students? So 1 square plus 1 square is 1 square is 1. I square is minus 1 minus 2I divided by 1 minus or minus is plus. So you get 1 plus. So 1 and minus 1 cancel. So what do you get? Minus 2I divided by 2. So what will get cancelled? 2 and 2 will get cancelled. You get the answer as minus I. Therefore, Z, the given complex number is equal to minus I, which I can definitely write it as 0 plus minus 1 into I. Correct, students? In the form a plus ib. Real part is 0, imaginary part is minus 1. Did you understand this, students? Very simple. 1 minus I by 1 plus I. You have to write it in the form a plus ib, which means you multiply and divide by the conjugate. 1 minus conjugate of the denominator. Denominator is 1 plus I. So conjugate of the denominator will be 1 minus I. So you multiply numerator and denominator with 1 minus I. In the numerator, if you see, it is 1 minus I into 1 minus I, which is 1 minus I whole square. Denominator is a plus b into a minus b, which is a square minus b square. Okay, students? And then just the expansion. Clear, students? Okay. Now we will move on to the next question. Let's look into question number 21. To write the relation defined in the roster form, write down its range and domain. Okay, students. Now, let's write the relation in the roster form. So R is equal to, first we take x value is 0. So it will be 0. When x is 0, x plus y will be 0 plus 5, which will be 5. Clear? If you want, let me write it in a tabular form so that you understand. So when x takes 0, x can take what all values? 0, 1, 2, 3, 4. So your x plus 5 will be 0 plus 5, 5. In this case, when x is 1, it's 1 plus 5, 6. When x is 2, 2 plus 5, 7. When x is 3, 3 plus 5, 8. When x is 4, 4 plus 5, 9. Therefore, the ordered pairs in the relation will be 0, 5, 1, 6, 2, 7, 3, 8, and finally 4, 9. Clear, students? So we need to write domain and range. So domain will be nothing but in the order pair. The first element will be the set of all first elements will be the domain. Okay. Domain is nothing but 0, 1, 2, 3, and 4. Clear, students? Now let us look at what is going to be our range. Range is nothing but the second value in the ordered pair. 5, 6, 7, 8, 9. Or in other words, this is our domain. All these elements which are here. And this is our range. Therefore, range is going to be 5, 6, 7, 8, and 9. Is it clear, students? So this concludes our answer to the question. Clear? Simple? Okay. Let's now look at the next question, students. Let A be 1, 2, 3, 4, 5. Define a relation R from A to A by R is equal to x, y, where y is equal to x plus 1. Write the domain and range of the relation R. This is exactly similar to the previous question. Right, students? Okay. Now relation is defined from A to A. Okay. Now A is 1, 2, 3, 4, 5. Define a relation from A to A such that R is x, y, where y is x plus 1. Okay. So now see here, what are all values of A? 1, 2, 3, 4. And the codomain is also 1, 2, 3, 4, 5. Okay, students. Now we need to write a relation. So what all values are possible, let us say, for x. Okay, and y. We know that y is equal to x plus 1. Okay. So now x is 1, 2, 3, 4, 5. Let us write it down. We'll see what are all possible, what are not possible. Y is equal to x plus 1. So 1 plus 1, 2. Y is equal to x plus 1. So when x is 1, it is 2. When x is 2, y becomes 3. When x is 3, y becomes 4. When x is 4, y becomes 5. But the moment I try writing x is equal to 5, then y becomes 5 plus 1, 6. But if you see, it is a relation defined from A to A. That means the codomain does not contain this number 6, right? But it is only limited till 5. Therefore, the last combination is not possible, students. Got it? In the earlier case, that was not the, no condition was given on what could be the restriction on x plus 5, correct or not? X belongs to this, that's all was mentioned. X plus 5, 9. There is no statement which says x plus 5 must be within some value, correct? So we could write all of them here, right? Whereas here, I will not be able to write all of them because it's clearly mentioned R is defined from A to A. So even in the value of y, all the values which are there must be belonging to set A. So when we start writing them, for 1 you get 2, for 2 you get 3, for 3 you get 4, 4 you get 5. 5 you are getting 6, but 6 is not in the set A. Therefore that cannot be possible. So now, what are all the possible pairs? 1, 2, 2, 3, 3, 4, and 4, 5 only. Okay, now let's write the domain and let's write the range. So as I have told you, the first element in the ordered pair becomes the domain. Of course, in functions, we will also include that we'll say if it is defined from A to B, then the entire set A is going to be part of the domain. Okay, students. Set of all values that are allowed for X. As far as range is concerned, it is limited to the values which are in the ordered pair. Therefore, it would be 2, 3, 4, and 5 only. The number 6 which we are getting, when we substitute the number as 5, won't be part of the range. Clear, students? Let's move on now.